And go. All right, the first one, I have here just the basic numeric problems. In other words, let's call this, I've had some students notice, yes, these problems do come from, let's call it 4th through 8th grade. But it's important to understand because if I started talking about exponents and there was somebody in the class that thought 1 to the 5th was equal to 5 because it was 1 times 5, and a lot of people are going to make that mistake when you change, the problem around. Like, for example, 100 to the 0. A lot of people, if you just change it a little bit, even if this is obviously not 5, this is not quite so obvious that it's not 0. And they're both not 5 and not 0 because this does not mean times. So yes, these questions do come from 4th to 8th grade, but I wanted to make sure that everybody understood them because otherwise people aren't going to understand what it is that I'm talking about. Now, number 1. 1 to the 5th means 5 ones. So the exponent is a count of how many times you multiply the base, and this is a base. So in this case, it's telling you multiply 1 5 times. 1 times 1 times 1 times 1, and then 1 times 1 is 1, times 1 is 1, times 1 is 1. It doesn't matter how much you do it, the answer is 1. Now this next one, it actually wanted an exponential form, so let's count them. 1, 2, 3, 4, 5, 6 zeros. So the base is 0 and the exponent is 6, because 6 is a count of how many zeros they times. Now this one I need to look for a pattern, so let me switch to reds. If I had just one negative 1, then that answer is obviously negative. And if I had 2 negative 1s, then that answer is positive, because 2 negatives make a positive. But what if I had 3 negative 1s? So that's a negative times a negative is positive, but then negative turns it negative again. And then if I had 4 negative 1s, negative, 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 these 2 negatives make a positive, and these 2 negatives make a positive. So every 2 negatives makes a positive. Okay, so let's look for the pattern. If you have 1 or 3 negatives, that made a negative, but 2 and 4 negatives made a positive. So in other words, if you have an odd number of negatives, that means that you wind up with 1 extra negative that turns it negative. So odd number of negatives is negative. But if you have even negatives, these pair off and make a positive, and these pair off and these pair off and make a positive. So evens are positive. So if you have an odd number of negatives, it's negative, and an even number of negatives is positive. So now I just need to look at the number 430 and decide, is it even or is it odd? So this number here, the exponent that counts how many of them you have. And 430 is even, and so that makes it positive. And we just discovered here that no matter how many times I multiply 1 times itself, I just get 1 at the end. So I just get 1 at the end. So it's positive because the exponent is even, and then 1 because 1 times 1 is 1. All right, so I've got some more just regular old numbers. So 3 to the 3rd, this is a count of how many 3's there are. There are 3 of them. 3 times 3 times 3. And then these pair off to make 9, and 9 times 3 is 27. Okay, and now I've got 2 questions. This is asking me, I'm going to put a 2 on the outside. So this is asking me what's inside 100 2 times, and this is asking me what's inside 700 3 times. I'm going to move all the problems up so that I have enough room here. Okay, so let's just move these up. Okay, so the number that's inside 100 2 times, if I factor 100, I can factor it into 10 times 10, and that means that the square root of 100 is 10, because 10 is inside there 2 times. And then for the 9s, for the cube roots, for these, you've practiced your square root tables since middle school so that you know that 2 times 2 is 4, and 3 times 3 is 9, and 4 times 4 is 16. So you've practiced these for a long time, but you haven't necessarily practiced your cubes, and you need to. Okay, so let's start practicing our cubes. 1 times 1 times 1, 2 times 2 times 2. And from now on, I'm just going to say cube. 3 cubed, 4 cubed, 5 cubed. 6 cubed, 7 cubed, 8 cubed, 9 cubed. Okay, these, you don't have to memorize them, but as you use them, you'll become familiar. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 5 times 25 is 125. 6 cubed, I'm going to have to start using, I might use a calculator pretty quick here. 6 cubed is 216. 7 cubed is 343, I think. And then 9 cubed is 729. But 8 cubed, I do need to go ahead and use a calculator. So for me, it's just how many times I've used them. So if it's a very common thing, then I'll probably remember it. 512. Okay, so all I did was put 8 caret 3 into Google, and I got 500. I typed in 8 and then a caret and then a 3. I got 512. So that means 8 cubed is 512. Okay, which one of these do we care about? We care about this one here. The number that's in 729 3 times is 9, because 9 times 9 times 9 is 729. So the answer is 9. All right, so the next bunch of questions here. This is another cube root, so let's look in our list for 216, and it's right there. So it's nice to, when you take the test, I would make a list of these so that you can just refer to it. So it's 216. This is the number 6 is in there 3 times. And I'm going to need more room for these two, so let me move things around a little bit. 6 times 6 times 6 is 216. Okie doke. So I'm actually just I'm gonna wipe this. Let me get rid of this one. Okay, so this is PEMDAS. Order of operations is PEMDAS, and that means I'm going to do the parentheses first. So yes, I do see parentheses, so I do that first. Yes, I do see an exponent, so I'm going to do that second. So let me highlight what it is I'm talking about. I do see a parenthesis, it's right here. Okay, so I'm going to do 2 minus 6 comes first. So this is going to come first. And then I do see an exponent, it's right here. And that's going to come second. After I do the parenthesis, then I'm going to square it. I do not see any timesing or dividing. So I do not see either of these two things, and I also don't see an add. But then the last step I do see is subtract. So the last thing I'm going to do is the subtract right here. Okay, so first I'm going to do parentheses, then exponent, and then I'm going to subtract. And here it goes. So in yellow, I'm going to do the parentheses. That's 2 minus 6, and 2 minus 6 is negative 4. Because there's 4 more negatives in the 6 than there are in the 2. And now I need to put all the other stuff in. So those parentheses are there, the exponent's still there, the negative's still there, and the minus 2 is still there. And now I need to do the exponent, that comes second. It's negative 4 squared, which is negative 4 times negative 4, which is 16. Positive 16, because 2 negatives make a positive. I'm doing this step right here. No, it's not 18, it's 16. No, it's not 18, it's 16. Okay, so 4 and 4 makes 16. And now I bring all the other stuff down. Negative 2 and the minus. And now I'm going to do the blue thing next, which was subtracts. So I'm going to take those two. Now, negative 2 and negative 16 are both the same, so it makes negative 18. And that's my answer. All right, so this is another PEMDAS. So P-E-M-D-A. It's always good to make a plan to start with. So let's see. Do I see P for parenthesis? Yes, I do. I've got this. So I do these first, and then I can do these at the same time, no problem. Do I see E for exponents? Yes. The next thing that I do is the squares. And then I do not see any of this stuff. No multiplying, no dividing, no addition, but then the last thing. In fact, these are the same 3 steps we did last time. So parenthesis, then exponents. So parenthesis, 4 times 2 is 8, and 2 times 2 is 4. So I'm done with that step, and I'm ready to go on to exponents. And for exponents, this is 8 squared, and this is 4 squared. So 8 squared is 8 times 8, which is 64. And 4 squared is 4 times 4, which is 16. And I need to bring down the minus. And then the last step is to subtract 64 minus 16. So I'm going to put those on top of each other so that I could subtract them. Take 1 away from the 6 to make 5. And then 14 minus 6 is 8. 5 minus 1 is 4. And my final answer is 48. All right, so these are the last on this page, the last 3 questions on this page. And the negative in the exponents tells you to take the reciprocal. And that means the same thing as divide. So if you see a negative, that means you're going to divide by this base, not times by it. And then the second thing, the exponent here is a count of how many of those there are. There are 3 of those things that you're timesing out. Okay, so I take the reciprocal, and then there's 3 of them. So instead of 10 over 9, it's 9 over 10 because of the negative in the exponent. Because of this, I put 9 over 10 instead of 10 over 9. And then because of the count, I have 3 of them. 9 over 10 times 9 over 10 times 9 over 10. Now, we've been practicing our cubes, so we know that 9 times 9 times 9 is 729. And that 10 times 10 times 10, we've been doing scientific notation, so we don't have to put that in a calculator. We know that it just means there's 3 zeros. So that's 729 over 1,000. Okay, next problem. This time, the negative here tells me to divide by 2, and then the count is 1. So this says divide by 2 one time. Okay, and that's what this says. 1 divided by 2. I divided by 2 one time, and I wound up with half of whatever it was. So 2 to the negative 1 says cut it in half one time, and I get a half. Now this one does not have a negative, so I just have a count here, 3. So I have the number 1/4, and I'm going to leave that alone, and I have it 3 times. 1/4, 1/4, 1/4. And I've been practicing my cubes so that I know that 4 cubed is 64. And of course, no one is going to continue telling me this is 3, because we all know at this point that 1 times 1 times 1 is 1. All right, so this was 729 over 1,000. Divide by 2 one time, and then divide by 4 3 times.